Hello, in this video we're going to talk about measurements in chemistry as well as units, and then we'll finish with density, which is a particular kind of measurement. So chemists measure the properties of matter using a variety of devices. So you might recognize some of these. We've got a ruler up here, a scale. Down below we have a beaker and a graduated cylinder. So rulers obviously are used to measure the length of something. Balances are used to measure the mass or weight of something. And in chemistry, we often use mass and weight interchangeably because even though earlier we said weight is dependent on gravitational force, typically we're measuring things on Earth, right? So we don't have to consider differences in gravity. So mass and weight, you might hear those used as the same thing, for example. All right, let's look at beakers. Beakers can measure the volume of something, and graduated cylinders can also measure the volume of something. And these are all items we're going to use in lab, so we'll become more familiar with them throughout the quarter. Now, when we are measuring matter, we do need to use a unit to describe what we're measuring. And units are really important. So we don't want to just list the number that we measure. We also want to list which unit goes along with it. So a quantity is an amount of something, and that is going to consist of a number and a unit. So again, the number tells us how many or how much of what we have, and the unit tells us what the scale of measurement is. So down below, we've got 5.2 kilometers. So we've got our number here and our unit. Now, what if we had just listed 5.2 and we didn't put the unit down? Well, that would leave somebody else very confused, right? They wouldn't know if you were measuring in inches, in meters, in centimeters, or in kilometers. So again, it's very important to write down the unit next to the value that you measure. Now, in chemistry and in science in general, we use what's called the International System of Units. This is also abbreviated as SI after the French way of saying it, Système International d'Unité. And this was established so that scientists around the world could communicate efficiently with each other. Now, in the US, we use what's called the imperial system. So that's going to include feet, inches, pounds, etc. But most of the rest of the world uses what's called the metric system. And the metric system is much more useful because it's multiples of 10. So it was decided that in order to clear up any confusion, in science, we use the metric system or this international system of units. There are a couple of other countries that use the imperial system like the US does, Liberia and Myanmar. And then you'll notice the UK or England and Scotland, they use a mix of the two. I believe as well in the US they tried to switch to the metric system in the 80s, but it didn't work out. We're very stubborn about our imperial system. All right, so let's look at the base units for this international system. So if we're measuring the length of something, we're going to use the meter as our base unit. And that's given the abbreviation lowercase m. If we're measuring the mass or weight of something, we're going to use kilograms as our base unit. However, in chemistry, we tend to measure really small amounts of chemicals. So we'll typically use the gram or even a smaller unit, such as the milligram. But we'll talk more about that in the future. Now, if we're measuring time, we're going to use the base unit of the second. If we're measuring the amount of something, the base unit is called a mole. And you don't have to worry about moles just yet. We'll get to that in a later chapter. The base unit of temperature is Kelvin. So I think I mentioned in a previous video that Kelvin is a temperature scale. We might not have seen this before, but we'll talk more about it later. And then if we're measuring the volume of something, we're going to use liters as our base unit. Now in chemistry, again, we're measuring smaller amounts, so we'll probably use what's called the milliliter instead of liters. So that brings us to density. Density is what's known as a derived unit because it actually contains more than one unit. So derived units are combinations of base units in the international system. And these units can be multiplied and divided, similar to numbers. So density in particular is defined as the mass of an object divided by its volume. So typically the units will be grams per milliliters, or G over ml. So for example, the density of water, or density of H2O, is equal to 1 gram over 1 milliliter. And density is a physical property. So remember earlier we said physical properties are something, or it's a property that doesn't change for an object or for matter. And when we talked about copper, copper had a very specific density, and that will not change for copper. That will always be the same. Now let's look off to the side here. We have a box with just a few atoms in it, and then another box with more atoms in it. So let's call these A and B. Which box do you think has the higher density or higher mass to volume ratio? A or B? B, right? So B has more mass per volume. So its density is greater. A has less mass per volume, so its density will be lower. And let's look at another example where we actually use numbers, right? So let's say that we have a 20 milliliter sample of liquid, and that is put into an empty beaker that had a mass of 31.447 grams. Okay, so let's do a little sketch here. So this is our empty beaker, and its mass was equal to 31.447 grams. All right. And then it says the beaker and the contained liquid were weighed and had a mass of 55.891 grams. Okay, so let's say we have our beaker and we add the liquid. And remember, the liquid had a volume of 20 milliliters. All right, so the beaker plus the liquid had a mass equal to 55.891 grams. And then we need to calculate the density of the liquid in grams per milliliter. All right, so to calculate the density of a liquid, obviously we need the mass and we need the volume. All right, so it looks like in order to get the mass of just the liquid, so just this liquid, we need to subtract the mass of the beaker because otherwise that's going to give us a different density, right? Or a false density. So what we'll do is we'll say that the mass of the liquid is equal to the total mass, 55.891 grams, minus the mass of the beaker, which was 31.447 grams. All right, so if you have a calculator, I encourage you to get that out so we can actually do this calculation together. When I type it into my calculator, I get a value of 24.444 grams. So that's the mass of our liquid by itself. And now to get the density, we're just going to divide that by the volume, which is 20 milliliters. All right, so off to the side here, I'll write density is equal to mass over volume. So that will equal 24.444 grams over 20 milliliters. So when we plug that into our calculators, let's see, mine gives me a value of 1.22 grams per milliliter. And you could write 1 milliliter in the denominator if that helps to visualize what's going on. But that gives us our density of the liquid. So again, on the last slide, we saw that density is a derived unit. So that means it has 2 or more units within it, right? And in this case, we have mass and volume. And mass is divided by volume. We also saw that density is a physical property of matter. And in this example, we were able to identify the mass of a liquid by subtracting the mass of the beaker that it was in, and then we divided by the volume of the liquid to get the actual density. Now, let's look at a slightly different way to express density. So, in the last example, we used milliliters for volume. Now, what's really interesting is that 1 milliliter, ml, is equal to 1 centimeter cubed. Now, milliliters are often used for liquids, and centimeters cubed are often used for solids. So let's look at an example where we have a solid instead of a liquid and we want to figure out its density. So in this problem, it says a rectangular object measures 4 centimeters by 3 centimeters by 2 centimeters. What is the volume of the object? So if you want to pause the video and try this on your own first, you can. And when you unpause, we'll go over it together. All right, so remember, volume of a solid object is equal to the length of the object times the height times the width. So we're just going to multiply these 3 numbers together. So 4 centimeters by 3 centimeters by 2 centimeters. And I don't know which one's the height, the width, or the length, but the general idea is that we're going to multiply all the sides together. And that will give us, let's see, 4 times 3 is 12. 12 times 2 is 24. And then we have centimeters cubed as our unit of volume. Now, down below it says the density of that object is 0.35 grams for every 1 centimeter cubed. So what is the mass of the object? Okay, so we said earlier that density is equal to mass over volume. And I like to remember this as DMV, like the Department of Motor Vehicles. So we're given the density and we're given the volume, or we solved for the volume earlier. So now we just have to solve for mass. We don't know what the mass is. So we can actually rearrange this equation to isolate mass on one side. We're just going to use a little bit of algebra here. So to isolate mass, what we could do is multiply both sides by volume. So volume is actually going to cancel on the right because we have it in the numerator and the denominator. So now we have that mass is equal to volume times density. All right, so we had volume times density is equal to our mass. Okay, so now we can plug in those values. So we have 24 centimeters cubed times the density, which was 0.35 grams over 1 centimeter cubed. All right, so it looks like our unit of centimeters cubed is going to cancel because it's in the top and the bottom. And that will leave us with grams, which is an appropriate unit for mass. So all we need to do is multiply 24 by 0.35, and that will give us our mass of the object. So when I plug this into my calculator, I get a value of 8.4 grams. All right, so this was a slightly different problem. We used a solid instead of a liquid. And instead of solving for the density, we were actually solving for the mass. So we rearranged our equation to solve for mass, and that gave us 8.4 grams. Now, I know that some people don't write their equations the way I do. Sometimes I know people will use what are called train tracks. So you might use something like this, and you might have set it up with 24 centimeters cubed in the upper left, and then 0.35 grams over 1 centimeter cubed. And that's totally fine. However you solve these algebraic equations is fine. I've seen it all. So don't feel like you have to write your equations the way I do. I just learned how to do it a little bit differently than that. But if you have any questions on how I set up this problem, just let me know. I'm always happy to help, and I'm always glad to clear up any confusion. But we'll stop the video there today. Next time, we're going to talk about prefixes for units. So how do we make a unit bigger or smaller? And then we're also going to talk about something called scientific notation, which is a much easier way to represent large numbers and small numbers. So I will see you in that next video.